Hello, this is TLV back with 100,000 diamonds. Oops. Good start. The computer started working randomly later, for some reason. I found a bug though. I can't add more memory to the... let's cheat in some RAM. I'll just show you quickly. RAM and back. It works on grass, but it doesn't work on frames. I think it's a Technic bug. And I don't think LRM cares about Technic back, because all that matters is feed the beast. Look, I can't place them down. But if I try down there, for example, it works fine, just fine. So, fucking hell. We'll just have to work with 600 bytes. I think I can code everything in 600 bytes. Hopefully. Hopefully, yeah. Hopefully, really. So these signals go by binary when you want to call them in the computer. So these two together will be 3. I'm just calling this one is 4. And this will be 5. So if I call number 5 here, I will call this and this one. So I have to make sure to just call the right one. And insulated, I think. So after 8 bits, I don't know if you have to allocate different strings, like 32-bit strings and stuff. I don't know fourth programming at all. Never touched it. Magenta, light blue, and we have yellow and pink, right? No? Lime. There we go. And some more. Yeah, I will not use transmitters first now. While testing, I'll use lamps. I did cheat in some lamps that I will delete when I'm finished. That's not what I intended. So now I think I will learn how to code the fourth, and I'll be right back, I think. And then I will show how to code, so I'll put an annotation in the video that you can just skip the whole video, skip the segment if you don't like it. So I will code whatever I need to code now, and then I will redo it on camera, I think, because I don't know fourth programming now. So if I would just try to code right now, it would take forever. So I'm just gonna learn the language, and we'll be right back, I think. Okay, be back later. Ooh, and I'm back again. Actually, thanks to video editing, the magic of video editing. This is actually not right back. It took me 3 days to learn fourth programming. So yeah, and it was bugging out. The ribbon cables didn't work here, so I had to use this setup here. IO expander straight into the CPU. And let's check the music. I'm gonna put on some really good track here while I code some Super Mario shit. Yeah, this is gonna be okay. I have no ribbon cables attached here. The IO expander goes straight into the CPU, and that works. This CPU is a emulated microcontroller, fully functional. It uses fourth programming language here. Page clears the screen here. Character returns changes line here. So I'll be using these guys. I'll explain a little more about it. And you can code a more advanced programming languages. So this basically uses assembly, like I showed you before. I have my disk drive is set on bus ID 2, the air expander on 3, monitor on 1. So you can check my disk on 2, monitor on 1, air expander on 3. Let's see. Fourth boot disk. FK2, let's throw this away. We'll start from the beginning. I have a basic idea now. I have written on some papers here what I'm gonna do. A lot of fucking shit. So this is, if you don't believe in evolution, seriously, you can just look at the evolution of programming, because this uses assembly basically. This program language is called Forth. I think you can see my mouse in this episode. I fixed that for the sake of this episode here. It's a stack-based programming language, and a stack is basically a queue, but it's not like your regular queue. It's a first in, first out queue. So let's say you have an ATM and there's a queue, and let's say there's a lamp on the ATM and there's a red lamp when you can't use the ATM and a green lamp when you can use it. So the queue builds up. There comes a new guy to the queue. 2 guys in the queue. 3 guys in the queue. 2 guys are in the queue. And then a new guy comes in the queue. The space in Forth is the separator of commands, values, variables, and anything. I will just do a very quick tutorial here because there are the tutorials on Forth. I'll do it my way, very quickly. So it's the queue. So first in, first out. So it's, and then the another guy comes here, number 2. We can check on the guys in the queue. Oh, I should clean it. Never mind, don't watch this shit. It's slow. I shouldn't spam it. Yeah, it's going well. Yeah, it's clean. 1, and another guy comes to the queue, and he goes first in the queue. So let's check the queue now. 1, 1, 2. Let's make space here. 1, 1, 2. And now the ATM turns green. You can withdraw your money. And it's not the guy who came first to the queue, the number 1, who's gonna be able to withdraw his money. It's the number 2, first in, first out. Yeah, it's not a fair system, but it's a stack. So he withdraws his money. A dot is to take something from the stack here, or from the queue. So I remove 2. So let's check the queue again. 1, 1, he's gone. Another guy takes out his money. 1 guy left. And then 2 new guys come. 2 and 3. Let's check the queue. The line is 1, 2, and 3. And the latest guy, the number 3, he takes out his money. Yep. And 1 and 2 is left. So first in, first out. And if you want to do operations in this operating system, you have to do it in a post position. So you want to have, I have 1, 2 now, and I want to plus them together. Let's erase them. Stack is empty right now. .s shows the stack without removing stuff from stack. Dot removes things from the stack. Okay, very quickly here. And so this is the same for all operations here. So I want to do 1, 2, and plus. The operation is always in post position. It comes for loops and everything. So this will take 1, 2, and plus them together. Oh, that was a slow operation. Now check the stack here. Show it. Show the stack. 3! I plus them together. Yeah, that's it basically. Making hello world. Colon to make a new word or a program. Hello. I got into the compiler. And Forth is basically assembly programming, the most fundamental language in computers. It's basically a layer put on assembly to make it more easy to maneuver. So I can make hello world here. If I want to write some text here, I do dot. And that sign, I just forgot it in English. Apostrophe, I don't know. Hello world. Bonk. And finish the thing. Maybe I want to do a new row here. Character return, turn 2 new rows. And hello, fucking world. There we go. Finished. And semicolon to finish the program. Alright, hello, my program. Hello, fucking world. Done. Yeah, now we can keep it there. We don't need to close it. And I'm gonna do a lot of shit here. And you can check the words in the operating system by writing words. I have added a few words here, but these are some of the words that are available to us. And for example, I want to add variables in this language. It's not as easy as other languages. You have to assign a memory address to it. So I will get to this in a moment here. Let's say I want to make a variable. Let's call it X. No, I already had it. J. Variable. No, okay. Variable J. Now J is a variable here. I haven't assigned any memory address. What happens? The stack is empty now. Let's see if I press J. What does the stack show? It's just a number here, 9286. It's the memory address on the computer where it's stored a J. So it's basically a spreadsheet. The whole the stack is a spreadsheet. To the left, we got the memory address, and to the right, we got the value stored in each memory address on the computer. Okay, I hope you don't follow me, because I don't follow myself. So if I want to see what's inside that memory address, I have to do an @ sign. Let's remove it from the stack, the memory address. Now it's empty. Well, I think this is Terranigma, one of my favorite Super Nintendo games. J @ this will take out the number inside the J. What's inside J? Let's check it out. Let's check what it is. 0. There's nothing there. We want to write something to J. We want to write 1 to J. The apostrophe here, or the fuck, English is failing me. That piece of shit character. That's how you write something. That's write and not read. So write 1 into J. Done. Because it's all in post position, like I just said. The operation is at the end. So, can you see my mouse? I hope you can. Well, basically I'm holding the mouse over 1 here. The 1 is put inside J, which is the memory address, and the operation. Stack is 0 here. Make some spaces. And let's take J. What's inside J? 1! Because I added J there. But if I just write J, what is on the stack now? 818. Another memory address. Well, you get the principle. But we're gonna define spaces with strings and etc. We're gonna allot memory. Oops. It showed memory address 818 now because we haven't allocated special places in the memory that are reserved. We have to reserve. Yeah, it's a fucked up language. It's annoying to work with, but we have to reserve memory for our variables. So I have to reserve memory. It's done by several commands here. Allot, for example. and that's why we want to work with strings here. I think I will not explain too much, and I will go along, and I think you can understand when I code how this is gonna be done. And we want to make a program that accesses our redstone signals over here, and it's done with going through the IO expander here. The IO expander can be accessed by IOX. That's the command to access the IO expander. And like I said before, it's all binary. So 1, 2, 4, 8. 256 bits on 1 byte. So if I want to turn on these 2 lamps, I have to write 1 plus 2 is 3. Just writing a 3 will turn on these 2 guys. 3 IOX. First value, then the operation. The operation is always in post position. Turn on these 2 guys here. Good. 4 IOX. There we go. Just the 4. But when you do a program, you want to reset the IOX too. 1 IOX, for example. Turn on the first one. But then you want to make it 0 again, just to be sure. Or there's a command called IOX reset. 2 IOX. The number 2. And then 2 IOX reset. It only resets this bit, so these bits can be the same. Let's try it out. If it works like I thought. So you have to be careful. That's a 3 IOX that turns on the first 2 in binary. Let's 2 IOX reset. It should only reset this bit, if I'm correct. Yep. So the first bit is still on here. So you have to be careful on what kind of commands you're using. 0 IOX. That's the IOX. So our programs will basically access these redstone signals under a period of time, which can be defined in the programs. And we're gonna make some programs where you can put in values, directions, you can choose depth of the quarry, and we're gonna make a nice interface. And I'm gonna start code it. If you want to see how to build this, you can follow me and build the Frame Quarry like I did, or you can just skip. If you don't like it, you don't have to watch it. And we'll start that in the next episode, I think. I will just fucking start with the coding. Just pump it up. And yeah, I got some memory here. That's why I'm building it in base, basically. Because I ran out of memory on my Frame Quarry. That's why I have the computer in my base now. I think I forgot to say that. That's the reason. I was coding my program off camera and coding and learning, and just ran out of memory. So I needed more RAM modules here, because my program turns out to be quite big. But this is the thing. You have to work with small programs, work small things, and then piece them together. Like hello 2. In this program, I can contact the other program. Hello, for example. It's quite a pointless, but that's how you want to make it like a tree. You want to build and build, make it bigger and bigger. It makes the same thing, right? But you want to expand on it and expand and expand. Like... Or let's redo that program. Hello 2. First it does hello and character return. So, hello again. Hello you piece of shit. So it's gonna call for the first hello program that we made. So this is how we're gonna make this. since you can't edit programs in Forth. Once you have compiled a program, you can't fucking edit. So if you want to do one typo, you're gonna be a sad panda. This super sad panda. That's sad. So we're gonna do it piece by piece and add programs and add them together to bigger programs and bigger programs, and in the end they will all connect to, and we're gonna make loops and if statements, etc. And you will see how to process. An if statement would be like this. Alright, then else, and then. Yeah, it's the wrong order. It's the same with a while loop in other languages. In Forth it's begin and then blah blah blah, you write something, and the right command is to exit the loop, you got the right thing, and to finish the while loop, you write again. So exit comes before again. It's quite weird. So if you put an if statement here, if blah blah blah, exit, else blah 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 blah, again, and it returns again. So that's it. Oh, it's gonna be a mess. But I'm gonna start slowly, and we're gonna assign strings and variables and values, and we're gonna read from the monitor here, blah blah blah. And I have my papers here, so we know what to do. So see you next time.